It's Thursday, December 5th, 2013, and school was closed today because sleet has been coming down constantly, pouring down out of the sky since 11 o'clock this morning, and it's now almost 8 o'clock at night. I'm worried the power's going to go off, so let's hurry and get this done and put it up on YouTube. We're going to be talking about geometric series. Here we are. Let's do the first one. Find the sum if it exists. Well, we don't know if it's going to exist, so let's take the second term and divide it by the first term. That will give us the common ratio. The common ratio is 1/5, or 0.2. So that means the absolute value of r is less than 1, which means it's a proper fraction, which means our sum really does exist. So let's find it. The sum of an infinite series, when it's geometric, is the first term divided by 1 minus the common ratio. So that will be 50 over 0.8, or 50 over 4/5. And a trusty calculator told me that 62.5 is the sum of this infinite geometric series. Now, let's try the second problem. Take the second term divided by the first term. We find out that the common ratio is 2, which is bigger than 1. So, of course, the absolute value is greater than 1, and so the sum does not exist. We say it diverges. When there is a sum, we say it converges. All right, now here are two sums written in sigma notation. And we're told on the first one, find the sum if it exists. Well, of course it's going to exist. Look at the top number on the sigma. We're only going to be adding 3 terms. This is a finite geometric series, which means we can add. We can add the numbers and we can come up with an answer, and it won't be any problem at all. We'll find A1. A1 is 6 times 1/2 to the 1 power, which is 3. So the first term is 3. The common ratio is 1/2. So the sum of the first 3 terms is going to be 3, parentheses, 1 minus 1/2, which is r, to the 3rd power over 1 minus 1/2. And so we'll have 3 times 1 minus 1/8, because 1/2 to the 3rd power is 1/8, over 1 minus 1/2, which is 1/2. Now 3 divided by 1/2 is 6. So we're going to have 6 times 1 minus 1/8, which is 7/8. And altogether that's going to equal 21 over 4. And that's our sum of the first 3 terms. Now, with the second one, r is going to be 0.5, so the absolute value of r will be less than 1. Notice this is an infinite sum, so we have to check that first. Yes, the infinite sum will exist, so let's do it. A1 is going to be 12 times 0.5 to the 1 minus 1 power, well, that's 0, isn't it? So we're going to have 12 times 0.5 to the 0 power. 0.5 to the 0 power is what? It's 1. Anything to the 0 power is 1. So our first term is going to be 12. So the infinite sum is going to equal the first term divided by 1 minus r. So 12 over 1 minus 0.5, that's going to be 12 over 0.5, which is 24. 24 is the sum of our infinite number of terms. All right, now we have a word problem. Let's try this. Suppose an employer offers to pay under the following conditions: 4 cents for the first day, 8 cents for the second day, 16 cents for the third day, and so on, always doubling the previous day's salary each day for 15 days. How much money will be earned? Well, let's find out. The first term is going to be 0.04, and the common ratio is 2 because we're doubling. So the sum of the first 15 terms, the total amount of money made, is going to be the first term, 0.04, times 1 minus 2 to the 15th power, divided by 1 minus 2. So this is going to equal 0.04 over negative 1, because 1 minus 2 is negative 1, times 1 minus 2 to the 15th power, which is 3, 2, 7, 6, 8, 32,768. So 0.04 over negative 1 is negative 0.04 times negative 32767, and so the amount of money earned in the first 15 days is going to be $13.10 and 68 cents, $1,310.68. Not bad for starting at 4 cents for the whole day.